Welcome back. In the previous video, we talked about the mean of the distribution of sample means. Now we're going to talk about the standard deviation. This happens to be a much narrower distribution of the samples of size 5 than the distribution of the individual items. It is much easier for an item to end up being outside of these boundaries. Okay, now why is that happening? Well, let's really quickly define what a standard deviation of a sample of means is. It's going to be called a standard error. And it happens that in order to calculate it, we would actually have to divide the actual population standard deviation by the square root of the size of our sample. Okay, and because we're going to be dividing it by something, it is going to end up being smaller. Now let's look at the example that we've been working with, the smoke detectors. Let's see what are going to be the parameters of this what are going to be the mean and the standard deviation or the standard error of these samples of 5. So what is the sampling distribution of sample means of size n equals 5 going to look like? Well, we know that the mean of those sample means of all of those samples of the size of 5 is going to be the same as the population mean. In our case, it was 60 months. So it's going to be the same thing. It's still going to be 60 months. Now, what is going to be our standard error? Our standard error, which is the standard deviation of all the sample means, it's going to be the standard deviation of the population, in this case 8 months, and we're going to divide it by the square root of 5 because this is the sample size for me. Pause this video really quickly, grab your calculator, and go ahead and figure out what it is. So here is my calculator. I'm going to have 8 divide by the square root of 5, and I end up with this number, which I don't know exactly how much it is, but there are 2 options to do this. You have this button right above the enter that goes and transforms it. And we can see that the standard deviation is going to be about 3.5777. We can round that to about 3.58 months. So if I am taking samples of 5 smoke detectors, their standard deviation, instead of being 8 months, is actually going to be only about 6 months. Okay, and that is very, very important because now it's going to be much easier for me to predict where my mean of my population going to be, because it is now much more concentrated than it was previously. So this is why we want to take samples, and the bigger the sample, the better we are able to predict the parameter we're trying to predict. If I'm interested in the mean of the population, the bigger my sample size, the smaller my standard deviation, because the bigger this denominator, the smaller the standard error going to be. All right? All right, in the next video, we're going to work out one of the examples from the book. See you then.